My name is Dewi Hughes and I work for the TAG project, and in particular on the genomics work. Mankind has been farming now for 10,500 years, although selective breeding is a relatively new thing. During this short film, we're going to go onto the farm, onto the abattoir and into the laboratory to look at new technologies such as genomic technology can fast-track this process. In order to develop an effective breeding program, whether it's for improved health, productivity, or in the case of this project, improved carcass traits, we first need to decide which traits we need to be selecting on. To discuss this, we've come to see Sean Hall-Jones, who has been performance recording his flock for some years and is very interested in the potential that genomics can offer his flock.
We're not here to look for the perfect animal, because I think these are few and far between. What we are here to do is raise the average of the flock and to increase the profitability across the board. What selective breeding allows us to do is to address problems within our flock and try to breed these out from generation to generation.
How important do you think performance recording is to your flock?
Yeah, EBVs is playing a big part in that. It allows us to select on individual traits. Obviously, the meat carcass traits have a direct correlation with profit. So yeah, it's getting down to the crux of the problems, analysing those and moving forward. This is a maternal breed. We're working with the clean. We put strong emphasis on the ewe doing her job, and this is measured through ewe efficiency. So we ask that the ewe raises her own body weight in lamb. It's of importance to us that we have a saleable carcass at the end of it and a profitable carcass.
Do you think using technologies such as genomics could have a huge potential to your flock?
Yeah, well, we're using estimated breeding values, and as the name suggests, they are estimations. Genomic breeding values or working to genomics can offer us greater accuracy into what we're already doing. It validates what we're doing because one problem and one negativity of the estimated breeding value is accuracy levels do fluctuate. Using genomics also accelerates our improvement. Obviously, we have to wait for progeny to hit the floor before we can gain that level of accuracy. So genomics offers real-time data from the word go, and also it can help us with traits that are hard to record at the moment or impossible to record. If we take meat eating quality, for example, that can't be recorded until the animal's dead. So genomics can give us information, give the farmer information, and I think if we use the example of meat eating quality, that's something that'll become more relevant in the future. So genomics can offer us an indication of what groups or what bloodlines are better performers throughout their lifespan.
And as you have a shed full of sheep here, and no doubt they'll be lambing very close together, how practical is it then to undertake that performance recording whilst lambing?
As we've said, we are performance recording. We collect as much data as we can. And we also work with Zoetis out in Dunedin, New Zealand, in looking for the Myomax gene. All progeny that's born, all male progeny, samples are sent out to looking for this gene, because I think it's paramount that we try and include that within our nucleus flock, especially if we go down the visual imagery route. From a national point of view, I don't feel the technology is there for us to work with genomics on a commercial scale as of yet. Other countries are proving that it's viable. If we look at New Zealand, for example, they have the CPT, the Central Progeny Test. They have thousands of ewes that are recorded, genotyped, DNA analysed, and that bank of information is there ready to be sourced for the world to see. We don't have that. New Zealand, another advantage they had was maybe 7 or 8 breeds they began with. We've got over 80 breeds used throughout the country, so it's a big task. Yeah. But I think if we are to compete on a global scale, if we are to compete in the global market, genomics is something that we must include.
So we have established that there is a significant potential in using genomics to increase flock productivity, and equally as important, the eating quality of the end product, which could have a significant impact on the consumer and the processing sector. To look at this in more detail, we've come to Dunbier to meet with the agricultural manager, Alison Harvey. Can you explain a bit further why Dunbier is supporting this type of project?
It's very important that a company like Dunbier support a project like this. We have key customers, and our customers know exactly what they want when they go to buy lamb in the shop. So they want a consistent product. It needs to be consistent in shape and size, but also in eating quality. And that's why this trial is a good one to be involved in, because it looks at all these different aspects.
So you mentioned some of the key reasons why you're working with us on this project, but can you explain a bit more about perhaps the potential of using genomic technology to your business?
The potential for us as a processor, as I mentioned, we're looking for consistency in product, and one of the challenges we face as an industry is the amount of different breeds and types of animal that we have, and if we could get something more consistent into our factory, then we'd be able to look at different ways of dealing with those animals.
I assume then working with farmers, which is the core of the business or core of your supply chain really, is very important. How do you see that relationship working?
Our farmers are key to us. Obviously they're the first part of the chain, and without them there wouldn't be one. So it's really important to us, and partly our responsibility, to make sure that we are involved in work like this, and then we're able to give them the information they need in order to improve.
If we now go down to the abattoir floor, where all the data has been collected in terms of the phenotype, such as the amount of saleable meat, which will have a direct impact along the whole supply chain. Comparing these two carcasses gives a very visual explanation of what we're trying to achieve through this project. Essentially, we are trying to determine which genes are responsible or associated with producing the carcass on the right compared with the one on the left, which have significant more meat, particularly the high value cuts such as the loins, rump and jigget. Perhaps we also need to bear in mind that the cost of producing both carcasses are the same, and the production costs are fairly similar. However, the financial returns from them are significantly different. For the purpose of this project, we have cut up 2,000 carcasses and undertaken detailed measurements of individual cuts of meat, so that we have robust data to base our genomic selection on. This process might seem daunting, but we need to bear in mind that this is a pilot project and significant enhancements can be done to make the process easier, particularly in data collection at the abattoir. As Sean suggested earlier, using data from video image analysis could make this process automated, enabling much more animals to be compared at a fraction of the time and cost. Then, so we've been on the farm, we've been in the abattoir, we're now here at the laboratory to see how the final process works. Is this a new technology?
It's relatively new. It's come along in about the last 10 years. So there are a range of commercial assays available now for humans, cattle, sheep, pigs, and other agricultural species.
And how does the technology work?
So it basically involves these microarrays. So we'll extract the DNA from blood samples or from nasal swabs from the animals that we're taking, and the DNA then gets washed across the surface of this slide. It'll stick on, we put it on the scanner, and that gives us a digital representation of the genotype of that animal that we can use for correlating with traits.
What other species have benefited from this technology?
So as I mentioned, there are arrays available for humans where it's used a lot in terms of identifying genes that might be predictors for type 2 diabetes or Alzheimer's disease. And in cattle, it's used for genomic selection, where you estimate the breeding value of animals to improve, for example, milk yield or beef carcass quality, similar to what we're doing with you guys in the sheep.
So we've invested so much time and energy on the farm, at the abattoir, and now here in the laboratories. What do you think this information and technology can offer the Welsh sheep industry?
There's quite a lot of potential there. So as long as you're recording the traits in your animals, we can then train computer models to take the genomic information we get and predict which animals are best to breed together to maximise your productivity for your trait of interest, whether that's carcass quality, eating quality, or disease resistance.
So we've gone through the process involved with genomics. We've certainly got a technology there, and there's also a demand from consumers and also from the industry. We've also learned that other species such as dairy, pigs and poultry have made significant advances in this technology. There's no reason whatsoever that we can't have the same advances within the sheep sector. There's no reason to be intimidated by this technology, and embracing it, I think, would offer a huge potential to the industry and ensure that we are sustainable and profitable for years to come.